So today we'll be solving for the point other than infinity at which the electric field is 0. So, just to kind of visualize this, we have, oh, I didn't label them. We have a negative particle and a positive particle, and they're both, they are both 1 meter apart. And for our own information, we do know that the electric field does go out for positive, and it does go in for the negative particles, and we want to find where the electric field is 0. So if we have a point somewhere in between, we will have a force going this way, and then we'll have another force going this way. So one of these will be from Q1 and one of them will be from Q2. But if we put a dot right here, we will have a force from our Q2 going this way, and we'll have a force from our Q1 going this way, which means they do have opposite signs, which means they cancel out. So we will be looking for the distance of a particle somewhere to the left of both of our particles. And we'll just write that down right here. To the left of Q1. Okay, and so we do have our formulas, and we do know that we are solving for our electric field, so we will be using this one. And we will want our electric field in the x direction, since there is only one dimension to this. Or, yeah, we don't need to add that. Our electric field will be electric field of 1. It'll be negative because it's negatively charged, and then we'll have the positive electric field of 2. And these will just be the equation right here, the KE, and then we'll have the charge of, and they will equal 0. We'll have our charge at 1, absolute value, and we will have our distance squared, R2, R1, and then we'll be adding the same equation, except it'll be with our second charge and the distance between our charge number 2. And we will be needing to do a little bit of, we will label a little bit. We will call this distance right here, we'll call it x. And we do know that this is the point that we will be solving to from the 2 different points. And for our first one, E1, Q1, our distance from this point to here is just x. So we can write that real quick. And actually, we'll just move this over to that side before we start adding in the variables. So we will end up with KE times our charge 1 divided by R1 squared, and we'll have it equaling KE times our second charge over the distance from Q2 to that point squared. And what we can see here is that from Q1 to that point we have X. So we will just plug that in. We will have X, and then we will have our Coulomb constant and our charge 1, which is 2.3 times 10 to the negative 6. And that will equal our KE times our second charge, which is 7 times 10 to the negative 6, and then we will divide that by the distance of Q2 to that point, which we can see is X plus 1 from Q2 all the way to the yellow dot. So we will have X plus 1, and it's squared. And from here we can do our cross multiplication, and when we do that we will end up crossing out the Coulomb constants, and it will end up looking like this. X plus 1. We'll have X plus 1 squared over X squared equals our charge number 1, which we have is 2.3 times 10 to the negative 6, over our second charge, which is 7 times 10 to the negative 6. And from here, we can just do the easy calculation. So we'll square root each side, cancel those out. And once we do that, we will end up with X plus 1 over X equals 0.5732. And then from here we will multiply both sides by X to get rid of that one, and we'll get X plus 1 equals 0.5732x. And from here we will just subtract an x. So then we get 1 equals minus, subtract 1x, make it easier, minus 1.5732x, and then we will just divide both sides by 1.5732. And we should get that our x equals negative 2.34, and our x right here, that is the distance from here to here. So we want the distance from here to here, so we just subtract 1 and we end up with it being 1.34 meters to the left of Q1.